The entire universe is a family. Small rocky planets are the kids and love staying close to the sun. Larger gas giants keep their chaos away from the kids, and icy polar members hardly ever come close to the sun. But they love it all the same. What is strange, though, is why the small rocky planets are so much closer to the sun than their big gaseous cousins. Something must have happened in the past to make the giants leave. Or did conflicts between the small ones and the sun have something to do with it? Before we get into the primary issue at hand, let's make an effort to get a better understanding of the distinctions that exist amongst the numerous planets that make up our solar system. In today's video we will discuss why are rocky planets closer to the sun? Before jumping into the main question at hand, let's first try to understand the differences between various planets in our solar system. So, what are the different types of planets in our solar system? The terrestrial planets. These are the stony planets that we discussed earlier. They are the shining examples of this piece. These planets are referred to as the terrestrial planets because their surfaces are stony and hard. Our solar system is home to a number of rocky planets, the most notable of which are Mercury, Venus, Earth, and Mars. Since we live on Earth, which is a rocky world, it is not difficult for us to conceive how these other planets would be, even if these planets are not composed of gases. This does not necessarily indicate that they are devoid of any form of a gas layer, as evidenced by our research into the atmospheres of Earth, Mars, and Venus. There is a possibility that small, potentially rocky planets exist in the habitable zones of between 20 and 50% of the stars in the night sky. Recent research has shown that the actual number is probably far lower, ranging somewhere between 2 and 12 at most. The fact that fewer rocky, potentially livable worlds have been discovered among the hundreds of exoplanets discovered so far could appear disheartening at first glance. In spite of this, one of the most startling discoveries that have been made after more than 20 years of study is that planets that are in the habitable zone are quite abundant. A great deal more information is required, particularly a deeper comprehension of the ways in which the size of a planet relates to its makeup. The gas giants. The enormous gas giants follow next after the smaller rocky planets in the solar system. It is believed that they have a very small solid core consisting of metals and rocks, despite the fact that their names imply that they are primarily composed of gases. In our solar system, gas giants like Jupiter and Saturn are mostly made up of helium and or hydrogen. People often call gas giants that are close to their stars hot Jupiters. There is more variety hidden within these big groups. Hot Jupiters, which are gas giants like Jupiter but orbit so close to their stars that their temperatures reach thousands of degrees, were among the first types of exoplanets to be found. The orbits of these big planets are so close together that they make their stars wobble a lot. They pull their stars in different directions, which can be seen as a change in the color of the light coming from the stars. In the early days of planet hunting, when the radial velocity method was used, this made it easier to find hot Jupiters. The ice giants. Following a long voyage that began with the Sun, we have at last arrived at the most remote members of this family, the ice giants. Neptune and Uranus are the two planets in our solar system that are classified as ice giants. Both of these worlds are bigger than the rocky planets, but they're not as big as the gas giants. They are located at great distances from the Sun, and as a result, beneath their gaseous layers, there exist icy surfaces and mountains. How did the planets that make up our solar system come into existence? Before we can comprehend why the rocky planets are located closer to the Sun, we need to travel back in time to when the solar system was still in its infancy, and the planets were still in the process of forming. Our Sun was formed when a nebula, which is nothing more than a vast cloud of dust and gas in space, was torn apart by its own gravity and caused a collapse. However, just a portion of the matter in the nebula was employed in the formation of the Sun. A significant portion of it continued to revolve around the Sun after it had been created. All of the planets originated from this portion of the nebula that was left over. The cores were formed initially from the dust particles coming together to form a cohesive mass, and then the gases around these centers. It is possible that more than 8 planets developed during this period of chaos. Nonetheless, these planets all crashed with one another, which resulted in the formation of newer, larger planets as well as cores. Well, do you like what you are seeing so far? Don't forget to like and subscribe. Keep watching because you don't want to miss the end. What happened that made the rocky planets come closer to the Sun? As was said before, the younger years of the solar system were characterized by a great deal of disorder. Much like the turbulent years of adolescence. Exotic and agitated moods pervaded every planet in the solar system, including our own Sun. There were a significant number of crashes, explosions, and heat waves that passed between them. The nature and order of our solar system were both altered in significant ways as a result of all of these catastrophic events. There was a time when the rocky planets that we see now also had enormous gaseous layers surrounding them, just like the gas giants and the ice giants do today. On the other hand, when the Sun was still very young and still quite furious, it released enormous amounts of energy and matter into the solar system. The rocky planets, which are the ones that are located the furthest from the Sun, have been subjected to the full force of these streams. This caused the planet's gases to escape with them, leaving only the rocky parts of the planets behind. These rocky parts went on to form the planets we know today as the terrestrial planets. The remaining 4 planets were located at a distance from the Sun, which prevented them from being influenced by these streams. As a result, they were able to develop into the gas and ice giants that exist today. The temperature of the early solar system is responsible for the stony composition of the inner planets and the gaseous composition of the outer planets. The temperature of the solar system increased as the gases in the system began to condense into the shape of a proto-sun. Temperatures as high as 2000 K were recorded in the inner solar system, and temperatures as low as 50 K were recorded in the outer solar system. Only elements with extremely high melting points would have remained solid within the inner solar system. The remaining ones would have been considered losers. Therefore, the things that are found within the inner solar system are composed of elements such as iron, silicon, magnesium, sulfur, aluminum, calcium, and nickel. The majority of these were found in compounds that also contained oxygen. When the inner planets were being formed, there were relatively few elements of any other kind that were in a solid state. The inner planets are far less massive than their more distant counterparts, and as a consequence, their gravity is not as strong. As a result, they were unable to draw significant quantities of gas into their atmospheres. Other elements, such as water and methane, did not vaporize in the outer regions of the solar system because of the lower temperatures there. As a result, the big planets were able to form there. Because these planets were more massive than the inner planets, they were able to attract significant quantities of hydrogen and helium. As a result, the 2 elements hydrogen and helium make up the majority of their composition. Hydrogen and helium are the most abundant elements in both the solar system and the universe. Do all planetary systems contain rocky planets in the inner reaches of their solar systems? Is this something that recurs in all of our experiences? Are there additional solar systems in other regions of the universe that follow the same pattern, with the rocky planets located closer to the star than the enormous gas giants? The correct response is no. Many other solar systems have been discovered by scientists, and in many of those systems, the planets are gaseous and closest to their stars. Therefore, the answer to the question of why the rocky planets are closer to the Sun lies in the past. In a time full of chaos for our solar system, where huge streams of energy and matter coming from the newly formed Sun blew away the gaseous layers of the planets closest to it, leaving them small and rocky. So, that's it for today's video. What are your thoughts on our video? Please hit us in the comments section, and subscribe to our channel for future updates. Thank you so much for watching.